Hey everyone, and welcome back to another episode of Building SwiftUI Components. In this series, I teach you everything you need to know to build reusable UI components in SwiftUI. Last time, I showed you how to configure a SwiftUI view using view modifiers and the SwiftUI environment. And today, I'm going to show you how to use what we've learned so far to register user-provided custom logic. To demonstrate this, we will add an onValidate view modifier to our text input field so that users of our component can use their own code to implement custom form validation logic. Let's take a quick look at the sample application. If you've watched the previous episode, this will look familiar to you. If you haven't watched the previous episode, go and do that now, up here, and I'll wait for you. So this app has a simple input form for validating email addresses, and you've probably seen this 1,000 times before. The user needs to provide their email address and then confirm it. So the form is only valid if the user enters a valid email address in both fields, and both fields need to match up. Let me show you. And as you can see, the validation state of the form changes as I type, and the error messages guide the user to enter valid data. And the submit button will only become active if the form is valid. Alright, so we implemented some of this functionality last time, and if you'd like to follow along, I encourage you to get the starter project from GitHub. The link is in the description below. To implement the custom validation logic you just saw in the demo, we will need to do a couple of things. First, we will need to establish a lightweight error type that will allow the user code to report any validation errors back to the text input view. Then we will create a view extension that we can use to register custom validation handlers in our client code. And finally, we will update the sample app and register a validation handler that can verify email addresses. So, without further ado, let's get started. So, let's first implement a custom error type. This will help users of the new API to communicate what exactly went wrong during validation. And we can then use the information in the error to display a message to the user of the UI. So validation error is a subtype of error, and it has a message property that we can use to say what went wrong. We'll also add an extension that conforms to localized error to make it easier to localize error messages. Next, we'll implement some infrastructure that allows anyone using our text input field to register a validation handler. And just as we did last time, we will use the SwiftUI environment to do this. By doing this, developers will be able to register a validation handler for each individual input field on a form. That's great if all the fields on a form are different and you want to perform validations that are specific to each individual field. But sometimes you want to perform some validation logic on all fields of a form. By using the SwiftUI environment, we can register a validation handler on a container view such as HStack or form, and they will be applied to all child elements. Okay, let's implement text input field validation handler and conform it to environment key. So the value of the key is actually a little bit more complicated than what we did last time. We want to be able to register a function that takes a string and returns a result type. Depending on the outcome of the validation, the result will either carry a Boolean or a validation error. Now, to register the function in the environment, we need an extension on environment values. Inside the extension, we implement a computer property named validation handler that uses the text input field validation handler key we just defined to read from and write to the environment. We're almost done. The final part of this infrastructure is an extension on view. This extension provides a method name onValidate that takes a closure that we will later call to actually perform the validation. You will notice that it has the same signature as the environment key we defined a minute ago. Okay, so next we can implement the code that handles the validation logic inside our text input view. This code needs access to any validation handler that might be registered in the environment. Okay, so let's have a look at how this works. To read a value from the environment, we can use the addEnvironment property wrapper. To specify which value we want to read, we use the validation handler key that we told SwiftUI about by implementing an extension on environment values. And with this in place, we can now enhance the validate function. Currently, this function just validates if the field is mandatory. And we want to keep this functionality, so our new code goes after this existing code. So if the mandatory check was successful, we want to fetch the validation handler. And if there is no validation handler, we can just end the validation. But if there is a validation handler, we will call it. And since the validation handler returns a result type, we can now handle the failure and success cases. If the validation failed, we set isValid to false and assign the validation message. This will trigger some updates on the UI. For example, it will display the validation message and a small label above the input field. Now for the success case, this will be similar, but now we set the validation message to an empty string because if the validation is valid, there is no message that we need to display to the user. Awesome. So we've got the infrastructure for our validation handler in place. Now we can go ahead and start using it in our UI code. We want to verify if the user enters a valid email address. Now, I don't want to bore you with writing regular expression code to verify email addresses. Instead, I've added a little helper function by adding an extension on string, and we're just going to use that. Let's do it. So let's head back over to email validation form. And now down here, we can call onValidate on our text input field views. We will receive a single parameter, which is the current text value of the input field. And inside the closure, we can now take that string value and call isEmail to check if this is a valid email address. If it is, we will return a success, and if it isn't, we'll return a failure result. So let's run the app again to see this in action. Okay, so let's try this. So this seems to work fine for the most part. But there is a small problem with the rendering of the placeholder string. It seems like we need to make sure it isn't shown when the input is invalid. Let's quickly hop over to the body of text input field and fix this. So we only want to display the placeholder text if the text in the input field is empty or if it is valid. Otherwise, we need to hide this placeholder text. All right, let's take another look. And now everything works as expected. Nice! So finally, to prove that using the environment is a rather powerful tool, I'm going to move the validation up to the form and remove the duplicate code. Let's run this again. And this still works like before. Pretty cool, huh? Okay, so you might be wondering if this is the correct approach for implementing input validation. Some of you might have used Combine in their view models to implement form validation, and that's a great approach as well to achieve the same result. In fact, we've been using a combination of both approaches in the series. Our view model contains a simple combine pipeline that uses combine latest to compute the overall state of the form. The answer to this question, as with many things, is a resounding "it depends." Let's discuss some of the pros and cons. So the advantages of using combine in our view model are: this might be the easiest way to set up if you're already using view models. And in many projects that follow an architecture that your team has agreed upon, this might be the path of least surprise as well. Everyone knows where to look for the validation logic. And last but not least, this means you don't have to write and maintain your own SwiftUI component. On the other hand, the advantages of implementing form validation in our custom component are: this might be a great option if you find yourself repeating the same code over and over again. It's also easier to ship to other people because you just ship your component. And finally, it helps to keep knowledge localized. The validation logic is right where you need it, attached to the input field. So the bottom line is, it depends. However, you can use the techniques I showed you today and in the previous episodes in other situations as well. Implementing form validation was just a way for me to explain those principles to you. And with that, our series is almost on the home stretch. Next time, we will look into a very important aspect of component development, and this box here will play an important role. I hope you've been enjoying the series, and if you did, why don't you tell a friend about it? If you'd like to stay in the loop, subscribe to my channel or follow me on Twitter. And as always, feel free to ask questions in the comments and I'll do my best to answer them. Thanks for watching, and I will see you in the next one.